Yeah, welcome to this screencast. My name is Kuda Mugara, and this is a screencast for Industrial Programming Coursework 2, Data Analysis of Document Tracker. In this project, which was an individual project, the learning objective was for us to develop a proficiency in advanced programming concepts and using object-oriented programming to develop a document tracker analysis app. And this is in this screencast, I'll explain the code behind the application. I'll explain the application, the different commands, using the command line interface, using the graphical user interface, and the different codes that I feel like are noteworthy, and the general overview behind the application. First things first, the application was meant to analyze the JSON data. So there was a huge data sets, like as big as 3 million lines being processed in this application. I'll actually demonstrate it using the 3 million lines data set, which is approximately 1 gigabyte, but for development purposes we use the smaller data set, which is about 10k, for just ease of computation. But yeah, the application can handle 3 million lines as well, which was like the minimum requirement at least. And yeah, as you can see, there is the PyCharm IDE. There is what the development environment. We use Python 3.8, and these are all the files that are needed for the application, excluding the data sets. These are the most important files. I'm going to remove the data sets upon submission. Yes. First things first, let's try to run the application. Let's just enjoy the application before we go to the code. First thing, we can run the application via just using the IDE, not using the terminal. And as you can see here, what you see here, the first input field is the document UUID. Document was a bit too long, so I omitted the word document here. Just may know that there is means the document, and then it's differentiated by this ID, because this one is the user ID. There is where we put the source file. For example, we can just, for now, let's just forget about these two fields. We'll get there later. Let's just look at the source file. The source file, maybe for demonstration purposes, for now I'll use the smaller one. Maybe let's use the 100k. Why not? Yeah, let's use the 100k. Just make sure you type the same name as your data, the file of your name. Okay, so that will be data.json, right? json.json. Yes. Now this is very important. Import data is very important. You can't do anything without importing data. For example, if maybe you wanted to do task 2a, it notifies you that you forgot to specify the user or the visitor. Actually, here is because you forgot to import, but it tells you something that this should be amended. Actually, it should be that you forgot to do something. Actually, you forgot to import. But the reason why it says this, it says you seem to forget the user, is because it actually needs the two fields for it to work. That's why. But maybe let's take something as important, something that does not require these two fields, like task 6. If you try to run task, is because you didn't pass in the file, so it wants the source file, but then we passed it. Why is it refusing? Well, it's because we need to import it first. So we'll get the progress bar loading, and we'll get this notification that we are getting our results. We need to be patient, and we need to wait until you get a notification that your data is ready to visualize. This is our notification. Now we can do whatever we want to do. First things first, why don't we start with task that does not require the two field. For example, task 4. In task 4, we were asked to do the reader profiles. We were asked to find the top 10 readers based on the analysis that how often do they diary event read time. Now if we click on task 4, this is what happens. The GUI pops up. It shows that the person who spent the most reading time was this one with this user ID with this amount of read time, and the lowest would be this one. So it does what it's supposed to do, and this uses the pandas library to sort out to do all these calculations. Now another important task that maybe we should look at would be that doesn't require the two fields, would be the view by browsers, like the different browsers that the users used here. Now this will be task 3b. If we click on task 3b, it will take a bit of computation, but it's fairly fast. and we'll get a pop-up in a few seconds. Yes, so basically here these are the names. So here this is the counts of the different browsers. We'll look at the code behind this plot later because it's a bit interesting, this code. Here it shows that Chrome has about more than 40k users. Opera was like the lowest with this other one which is unknown, but yeah, there's nothing we can do about that. Safari was around here and Firefox was about above 10k with Microsoft Edge here. So this abbreviations is Chrome, Opera, Microsoft. This one is unknown, Firefox, Safari, Android, and so on. They're quite intuitive. No need to explain too much on that. Now let's focus a bit now and do other tasks. But then for other tasks we need these two fields. So let's get a common field, yeah, and let's close this. We'll get a common field, or forgive my screen, and we'll just go to the coursework, also like test. Yeah, because we're using the 100k data set, let's maybe use this input field, use these values, so that we can see if what we get is exactly what we are supposed to get, right? Now for the user ID, now we use this one, copy. Yes, now we have already imported the data. There's no need for you to import the data again. You are done now. Just put the fields, because you've imported the data, the source file was specified, you are done. You can do your investigations. Let's start with task 2A. Here, what are we trying to find? We're trying to find the countries of the viewers of this document provided at the top. Once you do that, they're from the US, I guess. There's 40 of them from the US. Now, when we do the task 3B, classifies them into forgive me, it wasn't supposed to be task 3B. I'm repeating again the browsers. It's supposed to be task 2B, which now classifies them into continents. Well, from the specified what do you call it, the dictionary, the specified dictionary, they couldn't associate US with any continent, so it gave me NAs, so it was a bit weird. But the other countries which specify them properly, we'll look at those later. But the most important task, maybe it would be the task on 5D, which basically does it prints the sorted list of the also likes function. Because what happened here is we passed in a document ID, we passed in a user ID, and what we are asking for is we want all the readers here in task 5D. We want all the readers of this document, right? And then after getting all the readers of this document, we want for every reader find the documents that they read, and then afterwards sort those documents in terms of the most read document now, right? So if we want to visualize the feedback here from that function, it prints to the console, it does not pop to the GUI. So what you see here is the all visitors here. For avoid that, we say we are looking at this document. Remember, I passed this document as an ID. Look at the end fields like 72B5, and if you go back to the GUI, 72B5 is the same document. We passed in this document, and what we are getting from that function is that the readers, all the visitors who went to this document are this one and this one. Indeed, it's true, because this function does not necessarily depend on the input field of the user ID. And remember, we passed in user ID as this one, but even if we omitted this, it will still be the same. So now it then continues to be a little bit more informative by saying this reader reads also these other documents, all these other documents, and then this reader also reads these other documents. And now it sorts them, saying sorted by top readers. This document has reads 1, reads 2, then it sorts by top 10. But then again, these are the top 10 we get, so that's the result. That's the result we get. And the other task which is interesting would be my favorite task, which is task 6, visualizing the graph. So what are we doing here? You know what? Let's make it interesting. Let's remove this. let's remove the user ID for now and visualize the graph. Remember, the most important part is the user ID. You cannot visualize the graph without the document ID. Without the document ID, this one is an option depending on how you want to broaden your search space. So if we pass in the document ID as such and then the source file, we are good to go in visualizing the graph. This will take a while as well because the function, but then yeah, it's quite fast. So this is the graph that we get. I want you to pay attention to this guy here, the beef ID here. You see, the document of interest we pass is this one, and again this confirms the also like function that we explained in the console. These are the documents that this guy, and we actually have two readers, but they share this common document. Now if notice the difference, we'll get back to this. If we pass the beef as an argument, notice how different the graph is. It's not that much of a difference, but just pay attention. You see how it transformed. Now we are no longer seeing the other document that beef read. You know why? It's because the argument means we actually know what this reader reads. We don't want what he's read already. We want some things that we can perhaps recommend, some things that he shares he might be interested in. For example, this reader here read this document the same as beef, and then he read this other one and this other one and this other one, which means it's probable that beef might be interested in one of these documents. So yeah, but then if you look at this one, beef also read this one, but then here is because we didn't specify that we are searching in our target user is beef, so that's why the search space is a big broad. So that's the difference. You pass in the argument, you get this. You pass in the user ID, you get this. You don't pass in the user ID, you get this. They're both correct, but it depends on what as a user you want, right? Yeah. Now let's go back to the code. There's a lot to discuss about the code. So that's the basic functionality of the application. Task, this one, I think we've explored all the tasks. There's no task we have not explored, and we can just minimize the F for now. Let's just go to the top and see the structure, how this application is organized. Well, basically here is the imports. Here we are getting the imports here. Just a second. If you know, this section here is just the imports. We are trying to make our imports for running the app. There is no complications about this part. Now if we continue down to the bottom here, this function is for initiating. It starts up the GUI, starts up the graphical user interface, and this one creates the top level of the GUI. It's just a simple application creates. It's just a GUI code. This one is basically simple. Now let's look at the class. This is the most important class is the top level one class. This is basically where everything gets constructed. Our buttons, our labels, everything that you saw here in this graphical user interface is cooked. This is where it's created here. There is the manufacturing place of that graphical interface that you see there. The file name, everything is there. Now what I attempted to do is here, initially we have this DFD is basically a data frame. A data frame, I initiated it to none. This was just a strategy to make sure that I don't read in the file every time I press the button. To me, it didn't seem like an economic way of dealing for this application to deal with everything. Yeah? So here, what I did, I initiated it to none, and then afterwards I equated it to a variable of data. So this function fetches the data here. It gets the data, uses some function called data, and then I equate it to that, so that the data is shared across the different methods here within this application. Now this is just this function is just for the bar plot, that the progress bar is just for the progress bar. It's just a simple progress bar for the just aesthetics. And then the get data function is probably one of the most important functions. It fetches your data, but it uses the data handling module, which is specified here. It's just a separate module to separate the data ingestion from the visualization. Yeah, and then it reads the data, gives it the variable data, and then returns this variable data. It catches some exceptions, such as maybe the file is not available or what, all that. And then this one just extract the user ID from the input, yeah. And then this function here is responsible for viewing the country. Is just a simple using matplotlib. You just get we extracted we get the input from the user ID, the document ID, and then we pass in as a search criteria within our data frame. And actually we use pandas to read the data. We'll go back to that later. And we just use matplotlib to visualize. This is the same browsers, is the same idea again, but then here, like I said, it's a bit interesting because we use the HTTP agent parser, which basically detects as a string of you see here the method no here the method displays a tree view. No, that's wrong. I know, let me just explain it to you. This HTTP agent parser, it detects the browser from a string. It will know that which browser is this, and we just use matplotlib again to plot the browsers, and we just rotate them 90 degrees to avoid cluttering of the visualization. Now there is the top 10 tree. What it does, it is a simple function for now. It doesn't visualize anything. This just sorts them by the top readers. It gives the top readers of a certain document, and it sorts them in terms of the most read ones. And then here, as you can see, we use the data frame and largest to sort. This is actually a limitation of my coursework here, because the sorting is not custom. The sorting is fixed. It is always descending. You can never sort maybe in ascending order or so. So it's something that we need to rectify by perhaps using high order functions, but yeah, that will be done in future. But this one is viewing continents. Is basically a function which just it gets the document ID, and then it filters using the document ID to get the list of the countries, and then it uses the dictionary which is provided here. Countries, there should be a continents dictionary here. There's a continents dictionary here. We use this one to make the mappings for different countries and continents. So this is the function, and yeah, that's it. And then this function is very important because the same function that we use in the visualizing of that fancy graph there you saw. Let me just take you back to that graph. I really like this graph. That function, this small function, you might underestimate it. It's very powerful. And this one, it gets all the visitors, while this one gets all the documents. You pass in the it gets all the documents of these visitors, and this one, it gets all the documents of all the visitors of this particular document. Now here, the likes function, let's see at the likes function. Oh yes, the likes function returns the top 10 readers of the document, the top 10 readers of the document of interest. I mean, what happens is, first let's focus a bit on this function because it's one of the most important functions in the code. First we get the, forgive me, yes, first we get the document ID, right? That's the document ID there, and then here we're getting all the visitors for that document ID. This is just for making some space. Now what we do is, remember here we get all the visitors, but then this becomes a list. We traverse the list. How do we traverse the list? We take every visitor, and then for every visitor we get the document for that ID, and then we put them in a document container here. There is our document container here. For every visitor, we'll just make sure we put them in the document container. And now for the particular document, there's a kind of document container inside this. There's a smaller document container inside this bigger document container here. This one is the same as this one. We want to append, we kind of remove it to make it structured nicely for our visualizations later. We append the inner docs inside this empty list here we've specified at the top. Now what we do here now is we clean the list. How do we clean the list? We use inline looping by removing the NAs. That's the first thing, and then we clean it again. We didn't want to write a long code by removing the document, the document UID. We remove the document of interest. We don't want the document that we've already read. So I mean the document of interest, there's no need for it to be included in the list. Then what we do now, we use the collections library to count the most common, and then it sorts them. This is exactly what you saw here in the console. it sorts the documents by the most read documents, and it returns the sorted it prints the sorted documents. In terms of, it becomes a list of tuples, where the tuples is a document comma number of reads. So that's basically that. And now this function is useful for visualizing the graph. It just gets the size of the data so that it can use that to make a label here. Exactly what you see here, get size of the data, will be used to display this line here that you see. So that's why we need that function. Now this is one of the cool functions as well. It's long, perhaps it could be made more efficient in future. It's long but amazing. I think there was a lot of thinking process involved here. Let's just go through this one. It's one of the most important ones. It needs probably a pen as well. Now, first things first, this is enclosed in a try catch because so many things could go wrong. We'll see what could go wrong later. First things first, we get the size of the data for just labeling the simple node, and then we instantiate a digraph object, we call it dot, and then we create a node of readers. Remember what you saw earlier, the node where we have the node of readers. Here we have something like this. This will be the readers, and then we have a arrow pointing down, and then this will be the documents. So the labeling, the size of the data will be labeled somewhere around here. Now what happens is we create an edge between the, you see here, we create an edge between the readers and the documents, and then we label it that way. Now we use the arguments of the document ID, and we use the arguments of the user ID, right? Because if there are two cases, it's possible that we don't provide the user ID, and then what happens? So the program checks, did you pass in the user ID? There's the line here, and if that's the case, then create a list here, create a list of documents that we might want to remove later. These documents will correspond, this one here, they will correspond to the same documents that the reader has read, because here you see here the VU is the user ID. We don't want this the guy's documents. We already know what he reads. I mean, what's the point now? So what we do is we create a list that we'll use to filter later on. So here the document to remove here is remove DUID. So there's a document that we'll need to remove. Remember here is document to remove, is the list that we want to remove, right? Is the list of all the documents that this reader has read, and then we want to remove the document of interest here. We don't want this document to be involved, to be removed when we filter. Just bear with me. I know it's a bit confusing, but bear with me. Now if we didn't pass in the length, then you know what, create an empty filtering list. This is just the filtering list that we will use later, but then if it's empty, create an empty filtering list, right? Yeah. Now we move on and say, okay, all visitors now will be, all the visitors for that document will be get all the documents, get all the visitors for that document passes as an argument. Now if the length of the visitors is 0, so that seems like the document does not exist. Yeah, it's possible that no one read the document. What if you pass an empty string or something that doesn't exist? Yeah, it should notify the user that the document is not there. But if that's not the case, then the program will continue. For every visitor, in all the visitors that we got here, for every visitor, we want you to check if you passed in the, was the argument passed and was the visitor passed, because this is important for the shader, for the coloring part. Because if the length the user passed in the user ID, then they will be colored green. If they have not been, the user ID was not passed, then it will just be red. This is just for differentiation. The same thing you see here. If they are passed in, they will be passed green. If they didn't pass in, they will be just red. So that's exactly what this code is doing here. And now we move on. This is the case where we're traversing through all the visitors. Now we create a clean list, we remove NAs again, just like at the top. We create another one, and now here's the part where I said bear with me. You remember the document to remove thing. Here we are removing everything in the clean list. I mean, we are keeping everything in the clean list from this one. That is not in the document to remove. this one here, the document to remove, remember, is just all those documents that the reader has read, excluding the one of interest, because if we remove it, then we can't be able to visualize it like this here. We want to keep this one, but remove all these other ones. You see, like here, we want to remove all these other ones, but keep these ones. So that's basically what's going on there. Where were we? Yeah, so that's where we use the inline looping here. We are here. We use the inline looping to do that. And now again, we are done with the visitors. Now again, while we are doing that for every visitor, we create another connection node for the documents. If the document is of interest, we color it green. If not, we leave it blue. Exactly what you see here. You see this document of interest? I mean the shared document, not necessarily everything is document of interest here, but the shared document. So that's what's happening there. Yeah, so basically that's it. In summary, that's basically what this program does, and it's a cool program. It's a cool algorithm. I had fun while developing the algorithm. A lot of thinking involved. I know it can be made better, more efficient, but I believe things such as inline looping, such as list comprehensions, allow the program to be as short as possible. I tried my best as possible. And here is where we use the command line option, because we want our application to be able to run on the command line. Actually, let me demonstrate that before we run out of time. We don't have enough time. Well, first let me just check if the program runs on the command line just using the simple Python coursework2.py. This should initiate the GUI. When we run that, this should initiate the GUI. Yeah, it runs. Okay, so it was just a way of checking. Now here, to run it, we need to pass a few arguments. The first argument is let me just confirm. The first argument, you know what, let's use the command line now to reproduce the same graph or perform different tasks. We will see how this works. The way I've programmed this is, first thing that the user needs to pass is the user ID, which we pass in as -u. You just say -u and then the user ID. So let's go back to the GUI. Perhaps fetch the user ID from here. Fetch the user ID from here. We can just paste it there, and then the document ID -d, and then fetch the document ID from here. We can just paste it, and then we need to pass the task ID. Don't forget the minuses, by the way. Task ID, for example, like you remember the task that we were talking about here. For example, here, why don't we do task 6? Let's do task 6. No, let's do task 3b. Yeah, why not? We'll do task 6 later. Task 3b, if I pass task 3b now, and then I pass the file name -f, file name will be 100k, spelling _ data.json. Okay, let's just check if we did the correct thing. Yep. Let's just run it. Here, what do we expect? Well, we expect what we expect is the browsers, because I chose task 3b. We have to visualize the browsers, the different browsers that the users used. Well, my application is designed in such a way that you get prompts, because I want the user to know that they have to import the data. I want the user to know that the data is loaded successfully as well. So you have to press OK and then wait for the visualizing part, and then press OK again. Then you are done. Leave everything. You don't have to press anything else. You should be able to visualize the graph after passing everything in this command line. Well, yeah, voila, we have what we want. And now let's visualize the task for perhaps this update is distracting my view. Yes, it's okay now. Let's visualize. There's task 7 as well. Task 7 is the cool one. It was a late update, but let's just play with that now. Task 7 should invoke task 6. Task 6, which is visualize the graph, but then again you get the GUI to reproduce the graph again. So let's just cancel this GUI here and then invoke task 7. Once we invoke task 7 from the command line, give it a second. Just give it a second. It should fire up anytime soon. Because this is the visualizing of the graph. It takes a bit of time, and Unless I didn't do something correctly. No, okay. Coursework 2, Python, .py, .that. Yep, I believe everything is okay. No, I think I didn't run this. Let me just run it again. Yeah, now it's okay. Exactly, I didn't run the command, so forgive me for that. Yeah, so this is the, again, you have to bear with this. It's just to make sure that you don't do wrong, the user doesn't do the wrong things before they get that notification that the data was read successfully and it's ready to visualize. This is the most important part for me. This part, it shows you that you can now do whatever you want. So just press OK, and then we get the graph. You didn't have to press task 6, you just made it from the command line. And then the thing is, you will notice now that the GUI is now active. You can reproduce the graph again. You can just enter the same thing I've entered before and just reproduce the graph. That's it. So let's just cancel that. We don't need this now. Yeah, I think that's about it, unless there's anything else I need to cover. Well, like we said, we have another module which is just a short module for importing the data. This is the data handling part, and then this will be like the requirements.txt, and this will be the other GUI. There is another class here which responsible for viewing the top 10 readers, and yeah, that's about it. The rest is just a basic application. Well, thank you very much for listening. This was quite a long video, but this was an interesting project to carry out from the start. It's always amazing how blank you are, but at the end, being able to achieve such a thing, it gives you that sense of fulfillment. And I really enjoyed this industrial programming course. It's one of the most empowering course, I think, because right now I'm more of a proficient programmer. Yeah, probably my Python code is not that great compared to C# or Java, but this has empowered me a lot. Thank you very much.